today is going to be different because I have discovered the power of the microphone. Alright, does that work? Camera near? Sweet. Okay, we're gonna just pick up right where we left off and continue our tutorial for today. So today, this week, as I mentioned, we're just doing kind of like a quick deep dive tutorial to get people kind of level set a little bit, at least in getting started with R. So, the first thing before I start, does anyone have any questions from last time? Is there anything confusing or you'd like me to go over again? I'm happy to do that right now. No? Okay. But if anything comes up, don't hesitate to ask. So today we're going to start off by talking about data types, okay? So there are a bunch of different sort of data formats in R. Most of the stuff that we were talking about last time was dealing with numbers, but that's not the only thing that R can handle. So let's take a close look. Okay, I'm creating an object called this is a number, and I'm just assigning 1, right? And so if I execute this, it gets passed down to the console, right? It shows up in our environment tracker thing, right? And so I can see that object, I can see what is being, what number is getting stored there under that object. So this is a number. And sometimes you'll want to be checking the data types of certain things. This can be handy when you're like loading new data sets and you're not sure what format something is loaded in. Okay, and so you can do is numeric. So what do you guys think this does?
Yes.
Huh?
Yes.
Yeah, so yes, except that it's going to, it'll give a Boolean that is the equivalent of yes, right? It's going to say true or false. So when I have this function called is.numeric, right? The input of this function is the object that I'm checking, which in this case is this is a number, and the output is the Boolean of true or false. Okay, so I hit enter, and that's true. There is another kind of similar type of kind of number object. It is treated slightly differently. So who can tell me what an integer is? Anyone? No one knows what an integer is? Okay, I'm going to assume that you guys know what an integer is. If you actually don't know, then you might need to repeat algebra. Okay. Oops, sorry, this is an integer, this is a number. All right, don't hit enter, true or false? Is 1 a integer or a number? True? False. Sorry guys. So, you thought you knew what an integer was. No, so actually the reason for this, yes, 1 is an integer, but we, in a lot of programming languages, there's a special sort of formatting for integers. It's treated differently for kind of a variety of reasons, which we won't get into in this class, but just know that integers are treated slightly differently. I'll be honest, in data analysis, in a lot of the stuff that we're doing, it's highly unlikely you're going to run into this, but in the case that you do, I just want to make sure that you guys are familiar with the concept of the difference between a number and an integer. So you can program R to indicate that a particular number is actually an integer by having L at the end. So 1L tells it that you're assigning an integer to that object, And so if I instead check this is an integer, we'll see that it's true. Okay? Pretty straightforward. All right. Next, we're going to deal with a set of data types that I don't think we really touched on in the first day, but you can also deal with characters. Right? So in Python, this would be called a string, right? And so if we're dealing with words and letters and that sort of thing, we call this a character as opposed to a number. So you can check this. This is a character. Didn't run it. Okay. And indeed, we see true. Okay, what do you guys think? So how about this? I'm gonna run this. Is numeric. What do you guys think? True or false? False. That's right. So when I put quotations around something, then it denotes that you are using characters as opposed to any sort of numbers or anything like that. So in this particular case, despite the fact that the object is storing this 1, just storing the character 1, not the number 1. And in fact, you see it when I enter it into the console, there's a difference between how about this and what's getting reported when I say this is a number, right? You see there are quotes around that number. So these are two different types of objects. You'll note, so kind of in the weeds here, but here it's a double quotations. I use single quotations up there. It's not any different. So R treats these as equivalent. So I could have done this and it would be exactly the same as doing single quotes. And I just use single quotes because that's kind of what I was raised on and what I'm used to. So yeah, but at the end of the day, no difference between double quotes and single quotes. You can use both, but you can't interchange them like this, right? That doesn't work. But if I wanted quotes in the character string that I'm doing, I can do that by taking advantage of the fact that there's both things. So, quote like this, and if I store this object and I recall it, it will show the quote as part of that character string. Okay, didn't want to get into this yet. There's a slash here as an escape character to indicate that that it's part of the string and not part of the command showing that it's like a quote. Don't worry about the slash for now. We'll that may come up at some point, but don't worry about it for now. Okay. Questions? Confusions? I'm trying to make this as confusing as possible, right? Okay. The other one that we've actually now seen a couple times, this is actually kind of meta, right? This is a logical true, and then we're going to see if it's illogical by using a logical test. Okay, so the logicals are what R uses to deal with Booleans, so ones or zeros, trues or false, yeses or nos. It's all programmed in this way. We use true and false in here, so is logical true? It can be more confusing, but false here. Is false illogical? Yes, it is, right? So as long as you're in that 1 or 0 territory, it will say that yes, this is illogical. Is this illogical? How about this? What do you guys think? I see some people shaking their heads. Yes, that's right. In fact, characters are not logicals, even if they look like logicals. I'm just going to be thorough here. I said that you probably, so numbers you're going to deal with, characters you're going to deal with, logicals you're going to deal with. Unlikely you'll deal with integers, and you're not going to deal with complex numbers, almost certainly, okay? But we're going to be thorough, we're just going to cover this. What's the square root of -1? Anyone? Anyone remember what the square root of the negative number is? Yeah, I. So in fact, I can look at this object, and it's the real component plus the imaginary component. So this number is I. If you remember this from, I don't even remember where you learned complex numbers, to be honest. And we can test if it's a complex number. Okay, true, great. And we'll just kind of put that aside because you won't be dealing with complex numbers. But this is the full sort of gamut of possible data types that you can experience in R. Some of these, obviously, you're gonna run into a little bit more than others, but there you go. There are also, in addition to data types, there are also data structures. Okay, and so like a vector, we talked about vectors a lot on Monday. A vector is one of the data structures that you can experience. And we're going to look at some vector examples now. Okay. So vector 1, we can do 1, 2, 3, 4. Okay, and so we've seen this type of thing before. And just as a quick refresher, right, vector 1 is defined as an object where I am combining or concatenating these 4 numbers together, report it out, and it gives the vector containing these 4 numbers. Okay. What do you guys think? True or false?
True.
True? That's correct. So it is a vector, and if all of the elements of the vector follow a specific data type, then it will be considered of that data type. Okay? We didn't talk about this last time, but when I have a data structure, maybe I want to reference a specific value in that data structure. And so how would I go about doing that? Let's say I wanted to recall just the first element of the vector. Actually, we kind of touched on like positioning arguments and when we saw that 1-by-1 matrix, right? In this case, so in R, square brackets are used to denote positions and index positions. Okay, and so if I do vector 1, position 1, what do you guys think gets returned? 1. Yeah, great. Easy enough. Questions? No, all right. Vector 2. Now let's do a vector of characters. So instead of 1, 2, 3, 4, I'm going to do A, B, C, D. I'm going to go ahead and run that. Is numeric vector 2 false? Great. I know you guys know that. Is character vector 2 true? Great. Obvious enough. And vector 2 position 3. What am I going to return? C. That is correct. Great. Intuition is building here. Okay, so easy enough. And now let's make it a little trickier. So vector 1 was 1, 2, 3, 4. Vector 2 was A, B, C, D. Vector 3 is 1, 2, C, D. Okay, and note that the 1 and the 2 do not have quotes around them. Okay, and so we're inputting it as a number. Okay, so is numeric vector 3? Don't cheat yet. What do you guys think? True or false?
False.
False. Great. Yes, that's right. Because as I was saying, it is only in that category of all of the elements of the vector are of that category. And so when I say is numeric, it's like essentially asking, are all of the elements of the vector numeric? And in fact, they are not. So false.
Excuse me,
Yes.
is there a way to pull up the different elements? Like meaning pull up how many kinds of elements are in each vector?
Yes, but it might not be what you think. So let me do this part first, and then let's see if we can
That's fine.
answer that. Is character true or false? False. I heard some true, some falses. Okay. True. So what was I just saying? I was saying that all of the elements of the vector have to be of the same type. And yet, for some reason, is character is true, even though we input the numbers as numbers, right? And not, there's no quotes around the 1 and 2. Okay, so why is that happening? Well, if you guys took a quick sneak peek over there, you can see that vector 3, our 1 and 2 now have quotes around them. Okay? What's happening? So, vectors, specifically vectors, can only hold one data type. So, Tim, your question is almost kind of irrelevant here because they're always going to have one data type. Okay? And in this case, the character type kind of supersedes your numeric type, and your 1 and 2 get overwritten as numbers into characters. And the reason for that is I can represent a 1 and 2 as a character. I can't represent C and D as a number. Okay? So this is something that may come up in like a data set that you load. The reasoning for that is this right here. So let me give an example of something that happens. That is a common occurrence and can happen to you, and this is the reason why, and so you'll know the reason why and you'll know how to fix it, okay? Okay, I downloaded a data set and then I loaded it into R, okay, and then I look at it and I do like a summary of it, and I'll talk about what that is and what that looks like, but the summary will like tell you kind of what's, I don't look at the summary, I look at like the first couple rows, and there's one column that's got a bunch of numbers, and I'm like, great, let me look at the summary, let me look at the average of that column, and then it says error. And the reason for that is maybe you've got like a character somewhere in that column. Okay, so this is very common when you're trying to do a mathematical operation on a vector or like a column of a table, and it's not working for some reason. It's probably this. Okay, so keep that in mind. Okay. Any questions? Yes.
I still do not understand the integer. Is it?
Oh, yeah. So an integer is basically a whole like round number, like 1, 2, 3, 4, no decimal points. That's all an integer is. This particular, oops, sorry, I'm like using the wrong screen here. There are some computer sciencey reasons why we would want to distinguish like a number, like an ordinary number from like an integer. There are specific reasons why you would do this that really don't pertain to anything in this class. And for that reason, there is an explicit distinction in R about what constitutes an integer and what constitutes just like a regular number. And so I would say 99.999% of the time in this class, we will not be dealing with integers, you'll be dealing with just numbers. And the special case of integer, you can explicitly denote by using this L. That's all. Does that maybe help with your question?
I just wonder what's the function of L.
Oh, yeah, so that L tells R that, hey, this is not just a number, this is like a special number, this is an integer, that's all. It is a special case that you would only use to signify that a particular number is an integer. Yeah. So I could do something like this, like integer. I think this works. No, it doesn't. Unnecessary decimal point, right? Because you're not supposed to have decimals. But you can't do something like this. That should be. Oh no, it'll just overwrite it. Wait a minute. Okay, hang on. Now I'm. Now I want to know. Yeah, it doesn't work. And in fact, did this even work? Integer is integer, yeah. I will say, don't worry about integers unless it like explicitly comes up. And if that happens, then you can always come to me and ask me what the hell's going on. Okay, any other questions? Data types, structures that we've covered so far. Okay. We're going to do a couple more steps before we get to kind of the most common sort of data structure. We're going to get a couple more things out of the way here. So a vector, right, is this object that contains multiple elements, and that's arranged. What I've shown you guys so far is a 2D vector, right? It is just a set of numbers. A matrix is kind of like a 3D version of a vector, okay? And so we can do that like so. So we're going to look at matrix and array. So matrix 1 is matrix So I'm going to draw a 2D vector, a 2 by 2, and I'm going to put 1, 2, 3, 4 in it. So 1, 2, 3, 4, and I'm going to define it to be having 2 rows and 2 columns, right? We didn't have to do that for a vector because it's just like laid out in a line. Whereas here, right, you could have a matrix, you could have a 4 by 1, you could have a 1 by 4, you could have a 2 by 2, right? And so what does this guy look like? Matrix 1. Okay, so rows, columns. Note, right? Importantly, note that the way the elements are getting filled out in the matrix, it's going from top to bottom and then left to right. So 1, 2, 3, 4. Okay? Questions? Okay, so with the vector, remember square brackets are doing what? Position, yes, exactly. So I can put the index of the position and return that indexed element, okay? I can do the same thing with the matrix. Who can tell me what I would put in this bracket to return this element? 1, comma 2, exactly. Row, comma, column. And boom, 3, great. Intuition, building, you know, even if you don't deal with matrices that often, we will be dealing with a lot of data structures, a lot of 2D data structures, and the way that we reference elements in those data structures is this exact same. So row, comma, column. Okay. An array. What is an array? So we've talked about a vector, which is like a 2D type thing, a matrix, which is like a 3D type thing, and an array is the generalized version of these objects. So a vector is a 2D array, a matrix is a 3D array, but an array can be any number of dimensions that you want, okay? So I can create something like this. So similar to matrix, and just as a refresher, right? So matrix is a function with the arguments what I want to put into the matrix, and then function options about number of rows, number of columns. Array, another function. These are the elements that get filled into the matrix, and then the dimensions of the matrix are 2 by 2 by 2. Okay. So if the vector is kind of like a line, and this matrix is kind of like a square, right? This array, I'm making a 2 by 2 by 2 is kind of like a cube, right? So if I run this, array 1 and hit enter, it's got 1, 2, 3, 4 in the like first thing, and then in the next piece of it, 5, 6, 7, 8. Okay? Any confusions about that? Okay. So somebody tell me, how would so I'm asking for position arguments again. How would I get this number?
Two, 1, 2.
Alright, let's try that. 2, 1, 2. Great. Everyone hopefully sees how that works. Okay, so arrays, pretty powerful tool. Most generally, you guys will be working with vectors, okay? When we look at data structures in like tables and that sort of thing, like a column is basically a vector, and so most of the stuff that you're gonna be dealing with is gonna be vectors, and not very often would you be dealing with matrices and arrays, okay? Next one. We've got 3 more kind of fundamental data structures. These next 3 that we're going to look at will all be useful for you guys. So lists. So we had this example. Wait, what was I looking at? Vector 3, where we had 1, 2, CD, and then when we tried to input that as a vector, 1 and 2 got changed into characters. And you're like, well, okay, I understand why that's happening, right? But that seems a little inconvenient. Like, why can't a structure handle like 2 different data types, right? That seems like a overly limiting thing. So a list is the object or is the type of data structure that is designed to handle that. And this is kind of like, I call it like the trash can structure. Like you can literally throw anything in here and you just throw it in and it becomes part of the list, okay? And so let's take a look. So list 1, list, I'm gonna have 1, 2, 3, I'm gonna have A, B, C, and then let's put in some objects. We're gonna do entire vectors in here. Let's throw in our matrix, let's throw in our array. That all just gets thrown into the list, okay? So I'll run this, and if I type list 1 into the console and take a look at what gets spit out, oh hey, look, there's our array object that we did at the end. There's our matrix, there's our vector character, 1, 2, CD, there's our vector 2, there's our vector 1, here is the letter C, B, A, 1, 2, 3, great. What do you guys notice is slightly different about anything from this than you've seen before? In the outputs. Anything? Yeah, right? So double brackets. Okay. And so the double brackets are indicating basically the index position for things in the list, and then inside of the double brackets part of it, like if you had a vector, right? Like if I had a vector, then you still get that ordinary kind of output under this like double brackets heading, okay? So if I wanted to return the letter B, what do you guys think? How would I ask R to do that? So this time it's a little different. I'm gonna do 2 square brackets to indicate position. Okay. What would I put here? 5. Yes, it's the 5th object in the list. 1, 2, 3, A is 4, B is 5, so I put 5 here. Enter, and I get the letter B. Okay, what about the element 6 from our array1 object. How would I get that? What do you guys think? Or let me put it this way. How would I return array1?
You call list 12,
Sorry?
list number 12, double bracket.
Yes. Is it
Or
12?
object.
11.
Or
11.
11.
Yes. So 11, enter. That's exactly right. And I think the simplest way to think about this is if I do list 1 square square 11, that's the exact same thing as like just calling that specific object, right? And so this, so I'll do a comment, list 1 11 is equivalent to just saying array 1. So how did we call element 6 in array 1? We did array 1 square bracket what?
2, 1,
212, right up there. So it stands to reason that I can substitute array 1 for list 1 square square 11 close close, and then new square bracket 212, and that gives us 6. Okay? Questions? Yeah.
On line number 50, the double equations, what does that do
Oh,
again?
yes. So, okay, as a refresher, right? So there's equal equals is our notation to check whether or not these two are the same. This is a conditional, and this will always return a true or false.
Thank you.
Yes.
Is there ways to index the objects out by their name, or does it have to be by the numeric index they're given?
Yeah, so, okay. Yeah, that's a good question. So, I can do something like, this is the array. I can do this right. I'm pretty sure I can do this. Yeah. So I've replaced an indexed position with a name for the object being stored there. And the way that that would be called, okay, actually let me, just so it's not confusing in the actual notes, if you try to run this code again, I'm gonna call this list 2. List 2, so instead of square square 11, yes, you can shortcut it if you've defined a name for the object. And I can do $, this is the array. And that will return the array. The $sign thing, okay, might be confusing for some folks. If you're not familiar with this, we'll dive a little bit deeper into that in a second. So if you have questions about that, we'll hold off. But this is just to show that you can assign names to objects in lists and then call the object via the name rather than the indexed number position. Okay. The next one, factors. My least favorite. This is by far the most confusing. This is by far, well, in my opinion, the most confusing. This is also by far the most common place that you guys are gonna run into errors, almost guaranteed, okay? And also kind of confusing is the fact that a factor is actually a data structure, not a data type, which is like very unintuitive. I think there's kind of I think thus far, if you think about it, like there's a kind of clear distinction between data types and data structures. And factors you might think of as a data type, but it's actually a data structure. Let's just do an example so that we can see what we're talking about here. Factor 1. This is a factor. Levels. A factor is this. Okay. So let me do this. Factor 1. So if I look at factor 1, this is what gets returned. This is the factor. Levels looks something like this. Is this a character? What do you guys think? We got quotes around it? No. People are too nervous. Okay, so this is not a character, in fact, even though it looks like we've defined them to be characters. It is a factor. True. So factors look a lot like characters. They sometimes act a lot like characters, but there is a distinction with factors in that the whole purpose of having a factor is actually to denote that there is an order to these things, right? These characters or numbers or whatever. And so you may have a set of factors, and some types of computations care about the order in which factors are sort of presented, right? And so think about like on a survey. If you're administering a survey and you have like a Likert scale, right? And so something like, oh, I greatly dislike, I somewhat dislike, I'm neutral, I like, and I really like, right? So those are 5 like character objects, right? But there is an order to those objects. And so we would actually define that as a factor. And the factor preserves order, right? And so you could think of that exact example that I gave in like a long survey, and you have a column of those things, and you say, okay, in the first one, it's very dislike, and the next one is neutral, dislike, very much like, right? And so you can have a whole vector of these things, and then the levels will tell you kind of where you stand in that sort of rank order, okay? And so factors are actually powerful, they're relevant, but what ends up happening a lot of times is when you load in data, sometimes a numeric column gets loaded in as a factor, or even like a column of strings or characters gets loaded in as a factor, and then like weird stuff happens when you try to do operations on them. That's very, very common. So keep that in mind. Factors are, probably going to be the source of a lot of errors for you in the future. I can look at the order of things by using the function called levels, and whoa, sorry, I don't know what happened there. So levels, input, factor, and then it will spit back the order that those things are in. And actually, you'll note that there's quotes around these guys, because it's just saying that these particular things are characters. And like even, so if I do factor, if I want to look at a specific element of the factor, so 2 would be is, right? This character that we had put in, but even that is character factor 1, 2 is not a character. Okay. You can look at how many levels there are, n levels, like so. There's 4 levels in this one. And then you can reorder. Okay, so if we remember like vector 1, if I order vector 1, it goes from smallest to largest. Actually, okay, let me do a better example. Like if I do a vector 4, 3, 2, 1. Oh wait. I guess it's all ordering in reference to something. Okay, but for a factor, the order is 3, 4, 2, 1. So what's going on here? Any ideas? Yeah.
It's basing using the rows to figure out the order that the factor is.
That's right. That's right. So, I don't have a stick. Okay. So this, wait a minute. What's happening here? Isn't that 4? 1 second. Three, 4, 2, 1. Oh yeah, sorry. So A is in the 3rd position. Factor is in the 4th position. Is in the 2nd position, and this is in the 1st position. And so that's I had it backwards. But yeah, that's the order that's being specified in here. Make sense? Factors continue to confuse even me. One more thing. So, okay, should have shown this earlier. So vector 2, if you guys remember, is A, B, C, D. And if I can reference a specific element here, vector 2, position 2 is B, and I can actually do an assignment operator to replace a particular element, and I do blah, okay? And so execute this, and I look at vector 2, and now where it used to be B, I've replaced that character with a new element here as I define blah. Okay. Makes sense? We're all good? So I'm gonna do the same thing to my factor. And what do you guys think is gonna happen? Oh, I got a warning message, uh-oh. So let's take a look, factor one. So in second position of vector one, we originally had the word is. I'm trying to replace this word with blah. And when I execute this command, this and a factor. So what's happening here, right? So think back to that like survey example with the Likert scale. If you just put in a random thing instead of the answer, we have defined the factor to contain only certain levels. And if you put in something into this factor that is not defined as one of those levels, it's just like not a thing, right? Think about it this way, right? As I was saying, factors are basically ordered objects. And so you want to put in a new object, well, I don't know where that goes in the order. And so, and it doesn't work. Okay? Questions about factors? Okay.
I'm sorry, for this very final one that you did right here with the factor. The reason it's not working is one more time, why can we not replace the factor?
Yeah, because we have specified that all of the objects in the factor are related to each other in some way based on an order. Okay? When I put in a new object without defining the order, where that would stand in this levels part, then it's just not able to understand what that object is, so it won't put it in. All right. The last data structure that we will talk about, and kind of the most relevant for you, is data frames. So these are kind of like the tables that you'll end up dealing with. So data frames is actually kind of the default type of way that R handles like a lot of these, I want to say data tables, but but I'm trying to avoid that because there's actually a package called data tables that is actually separate. So anyways, if you think about some data that you store in Excel, like this is the data structure that is like most equivalent to like a typical thing that you might find in Excel. Data frames, again, is like the base version of this in R, but actually there are kind of two very common sort of more advanced or extended versions of the data frame that are a little bit, I would say, more robust. They're a lot faster. They can handle larger amounts of data. And so I'm not going to explicitly cover that in this class, but I will provide some resources for folks for those kind of extensions of the default. And in fact, like I don't really use data frames anymore. I use one of those extensions, which is data tables that I was talking about. The other one is in this universe of packages called, it's dplyr. Okay, so so let me put this in the notes. So advanced versions are dplyr versus data tables. And there's like a whole, debate about which one's better. And it's clearly data tables, but if you want to use dplyr, that's fine too. And actually I have, if you're used to one or the other, there's actually a nice guide that I can provide that kind of shows you how to translate between the two. But we're going to deal with kind of the simple fundamentals, which is data frames, for today. It's not often, I would say, that you'll kind of manually be making data frames. Most of the times what we're talking about in this class is going to be like loading in data. And I will show how to do that, but let's again just do a couple of the fundamentals. Okay, so I'm going to build a data frame manually. And so this is just a totally made up data frame. And as you kind of follow along, either if you're copying or just watching, what is happening is I'm starting with a word, I'm having equals some vector, and what essentially is getting built out is the name of a column and then the entries going down the rows. So I have a column called student, I have a column called ages, a column called gender, and so this is going to be factor, something like this. Okay, and then we'll have levels equals so, and we'll have a column here. Maybe this is like SAT scores or something, or GRE scores. Okay. So this is actually one of the nice features of RStudio is like the color coding. I just made a mistake where I didn't put a parentheses around verbal score, and it shows up as black, whereas when you have quotes around a character, it shows up as green. So this is like an easy visual indicator to me that's, hey, you've made a mistake, and so I'll go here and do that. Okay. So here is a custom data frame that I've made. I run this thing, and it does show up over on the right-hand side again in my global environment that's like storing all of the objects. If I type in student data here, bam, looks something like this. And so this would be, right, kind of your typical kind of data structure that you would see, again, like in an Excel file, right? Column names and then the entries under each column. And in fact, right, it's kind of easy to visualize it in the console here because it's like a smaller table, but you can imagine that you could have like a much larger data set. And if I wanted to actually visualize it, again, one of the nice things in RStudio is that I can do that. I can actually go over to my global environment. I mentioned this last time, if you click on it for a data frame, it will pop out this thing, this table, and this is right, like your typical thing that you can visualize data in. Okay. Great.
Can I ask a question?
Yes.
I'm still trying to wrap my head around factors, and I'm
Okay.
wondering why you included, like when you made the gender category, or you had levels there. Is that saying like the only for like male or female?
Yeah, so no, so actually, in fact, I could put in other levels here. And what you would see is actually still the same thing.
So
So-
would you have needed to include that at all?
So I could have done this, so in fact, I could have entered this in a couple different ways. Okay, I could have just entered this without the factor, and with just these, and without the levels, right? And that actually works. And what would end up happening is I would define this table and I'd have this column, but that column would be a vector of characters and it would not be a factor. Actually the reason why I put it in as a factor was just as a demonstration actually, because what I'm showing you here is that in this table, you can have different data types and different data structures within one table, okay? And actually, there is a function called structure, str, and when I run this function on a data frame, it will tell me what type of vector a particular column is. So student is a vector of characters, student 1, student 2, student 3. Gender is not a character, it's a it is a column of factors that have 3 different levels. Yeah, and so actually, I actually could have done factor MMF and not included the levels, and it would assume by default that M and F are my 2 factors. And when you do that and you don't specify the levels, the order that is assumed by that operation, by that function, is just alphabetical. So F and then M. Okay. Does that make sense?
Yeah.
Okay, great. Yes. Any other questions? So, I mentioned before that you could do summary function. So this is kind of a handy function. Let's say you got a bunch of data and you just want to know a little bit about like what's contained in the data. I hit enter, and actually let me pull this up. Okay. So what summary does is it tells you a little bit of information about all of my different columns. Okay. For any numeric column, it will tell me the minimum value, the maximum value, the first and third quantiles, and then the median and the mean. Was that a question? No. Okay, sorry. And then for characters, it's just gonna tell you that it's character. For factors, it will tell you how many of any individual factor there was for all of the levels. So FM non-binary, 1 female, 2 males, and 0 for non-binary, and then numeric is the same as before. So sometimes one of the easy ways to see when you load in data, if like numbers have been loaded in as factors, do a summary, and then when you expected to see this, but you saw like counts of different numbers, that means you've loaded it in as a factor, not as a number. Okay? Questions? Okay. jumping back over here, pull this down. If I want to look at the column names, we can use that using the function names. And you get student ages, gender, math.score, and verbal.score. And actually, you can be a little bit more specific here, because when I call student data, I see student ages, gender, math score, verbal score for the columns. But actually, you also see a 1, 2, 3 here on the left-hand side, and those are, it's kind of invisible for the most part. Like most people just see this, but this is actually a thing. Those are the row names, and so to be a little bit more specific, the default is names. We'll call the column names, but you can do call names, which will do the same thing. Is it called names? No, that. Is it this? Yeah. You can see that call names is not a very commonly used function because names does the same thing. But actually, right, you do have row names technically, and those are 1, 2, 3. And yeah, if you're a psycho and you want to name your rows, you can actually do that. I don't recommend it, but you can reference them this way. Okay? Questions? Okay. So now let's talk about, oh yeah, sorry, go ahead.
If you put an index for your data frame, will the row names give you the same as like your indexing column or?
Yeah, okay. So okay, let's do this. A, B, C. I'm now making row names. And so now when I press this, it's A, B, C instead of 1, 2, 3. And your question, if I'm getting it correctly, is that can I call something by a name?
I may have just had Python and R mixed up in my head for a minute, I think. I was thinking indexing and,
Okay, yeah. So it's very similar. One distinction with Python, so yeah, you can call things by names, and I'm going to show how to do that in just a second. When the biggest difference between R and Python, one of the biggest differences is in the indexing, when you do it by number, like a position element, Python starts at 0, but R starts at 1. That's probably the most common trip up for people who are like moving in between R and Python. Okay. So that maybe wasn't what you were asking, but actually we'll still play around with this a little bit. So, position arguments. This is going to be the bread and butter of a lot of like data parsing and filtering that you guys are going to do. So, I will say like what I'm talking about right now, what I'm lecturing to you guys about right now is just to introduce you to the concept. You learning to do this just comes from experience, right? And so doing the homeworks and doing whatever projects and research that you guys are doing, you know, this will become secondhand nature to you. But if this is your first time doing it, it'll be maybe a little bit confusing. It was for me when I was learning this. not where you're learning it, this is where you're getting introduced to it. Learning it will come from like doing the homeworks and doing the work. So, we talked about reference to elements in my table, right? So we're building off of, finding it in vectors, finding it in matrices. It's the same thing, like I was saying, right? So if I do student data 1, comma, and I'm just going to leave the column part blank, what do you guys think happens? What gets returned? So, yeah, I saw you doing the finger thing.
All of the arrows.
The first,
The arrow,
the
first row.
The first row, yes, that is correct. Okay, so remember, row, comma, column, RC. Yeah, so 1, comma gives me the first row. Student data. Okay, what about this?
The first two.
The first 2 rows, exactly. And if I do this, 1, comma 3, intuition, right? This will give me the first row and the third row. Great. And for fun, what do you think this returns?
The second row.
The second row, right? Because we were psychos and we decided to name the rows. You can reference a row by the name, which is, I don't think I've ever done that before. But I'm pretty sure this works. Yeah. Okay. Good. Whew. But that'll come into play later, right? Because you can probably do the same thing for columns. Okay. So for columns, comma 2, right? So this is going to return the second column. Great. Well, okay, it's a little different. When I return the first row, you are returning a data frame, right? Because in order for me to tell you about the contents of a row, I need to preserve the differentiation in data types between columns, and the way that I do that is in the data frame structure, right? And so when I return a row, you get a data frame back. When I ask for a column, I do not get a data frame back. I get a vector back, because in a data frame, columns correspond to vectors which only contain one data type, and so I can minimally provide you all the information in just a vector and not have to do it as a data frame, okay? So that is one important distinction between calling rows versus calling columns. If I want to do row 3, column 2, I can do that, and it will just provide the elements, right? It's not going to provide all the information in the data frame. I can reference things, by name, as we saw with the row name. So if I do something like this, it will return the column of ages. Great. I can also do this weird thing here. So we saw an example of this earlier with the list, when you're calling names. This is just put in as a shortcut, okay? This works perfectly fine. And when I did a lot of stuff in the past, I very commonly would do it like this. But actually, what I would say is that line 84, I think is kind of a better practice to do. And there's a couple like subtle reasons for that. Well, okay, so I would say, you know, this is a perfectly fine shortcut. Feel free to use this, but know that I don't know if I'll get it all for saying this, but I do think doing it like this is kind of a better practice. So one easy example of why that is that I can call multiple columns, right? Like I can do C, ages, and gender. Okay. Note that in this case I'm calling columns, but I'm getting a data frame back, and that's because these are two vectors of two different types, right? They're like, yeah. So if you do call more than one column, you will get a data frame back. Yeah, so this example, you can't do that with the dollar shortcut thing. Okay? And there are some like subtle things where actually you would want to do one versus the other, but these are kind of more advanced in niche cases. You probably won't even run into that in this class. Okay. And I can do something like this, 2, verbal score, so I can refer to an index position in a row and the name in the column. And I guess since we did the row naming, I think we can do this as well. Should get the same thing, yeah, cool. Great. Questions? So I'll kind of reiterate again, data frames, this is our bread and butter. You're gonna be doing lots of things with handling data frames, manipulating data frames, filtering and parsing in data frames. So just know that, you know, all the stuff that we're going over today, it's all available online as a resource, and so you should, yeah, if things are slipping your mind with regards to some of this stuff, you can always refresh your memory. These notes that we're typing in class are all posted on Canvas. Okay. So the last thing that I'm going to show with manipulating these directly. So let's say that I wanted to do kind of a finer filter here, okay? And we're kind of trying to build up to final what we want. So hopefully you guys can see the logic of these things. Okay, so as I discussed, student data, $verbal dot score, that's going to return the column. Now, let's say that I wanted to do some operations where I'm like filtering to specific things in a table, right? Let's say I wanted to know which students scored less than 510 on the verbal score. And you know, in this case, it's like, it's kind of silly, I could just like look at the table and tell, right? But let's say you had a data frame with 10 million rows that you couldn't possibly even visualize the data, you just wanted to extract portions of it. How would we go about doing that? So you can do, in the square bracket portion, I can ask to look at specific rows via booleans, okay? And so if I were to do something like student data true, false, true, what do you guys think gets returned here? The first and the third rows, that's right. So keep that in mind as we do this, right? This is how filtering in R works. Okay, so verbal score is less than 510. So we've talked about certain conditional operators, right? So equals equals is one of them. So if a thing is exactly equivalent, but I can also look at if things are less than or greater than. And I hit enter. So 500, 620, and 800. When I do this operator, it's basically asking, is this number less than 510? Yes, it is. True. Is this number less than 510? No, it's not. False. Is this number less than 510? No, it's not. False. Okay, great. So, student data, dollar verbal score is less than 510. Come. So we just ran this line 93, and I'm taking that and I'm putting it inside the referencing thing, right? My square brackets. So whatever this answer was, true, false, false. Imagine if I just took this out and I put C, true, false, false. Okay? Then this will return what?
True, false, false.
The first one.
The first row. So the inside part is true, false, false of this bracket, but it's like saying student data, C, true, false, false. And I do that, and the first row gets returned. And so what I've done is I said, okay, take the table and return to me the rows that fit this criteria. Okay, so this is like one of the most powerful tools for doing kind of data filtering. My original question was, what is the student name? Give me all the student names of people who scored less than 510. So this actually is not what I want. This is the whole table, right? So I can do something like this, exactly the same, except I'm just gonna return the the column with the names. So student, and that'll give me the name of the person who did less than, and names of all the students who get less than 510 on the verbal score. I can also do this. Student, it's the same thing, kind of. If I use the same filter as in line 94, and I just have the dollar student here, it looks something like this. And if I hit enter, what do you guys think will happen? Anyone? Error. Oh, you guys are too keen. So can you explain to me what the error is?
Yeah, because data student is in vector and it only has one dimension.
Yes. So you don't need the comma at the end, right? So comma is indicating row, column. Student data dollar student is already a vector. And so I'm saying this. And in fact, I want to build that intuition here. So student data dollar student, hit enter, it is a vector student 1, student 2, student 3. And actually what I'm returning is for a vector, I'm going to say true, false, false, it will return the true. And that's how I'm getting student 1 this way. So this is an alternative version of line 95. They're exactly the same in what they would return. Okay. Okay. Any questions? All right, we're gonna do couple more things for today. Okay, so the next concept I want to talk about is data merging. So this is, again, a common tool that I think will be very useful for everybody. You know, I may have like multiple data sets and I want to combine them, right? And so merging is the tool in which we do that. But actually there are lots of different types of merges. And so we are going to cover that. So let's say I have two tables. So table 1, and I will have a column X and a column Y. And let me see. Okay, I will have A, B, C, D. And then maybe this will be 1, 2, 3, 4. And then I will have table 2. And this will have a column Y and a column Z. And this might be 3, 4, 5, 6. And this might be, hang on, am I setting this up right? Otherwise, like this actually. X, C, D, E, F, and this might be 5, 6, 7, 8. Okay, so suppose, for example, you have, I don't know, you have some data on like car sales in different regions and like different counties of California. And you want to like correlate how certain cars are being sold with like demographic information about those counties, right? And so you might have something like census data on like income and education and ethnicity and that sort of thing. And I want to combine that information into one table, right? And I'm going to combine it on the basis that like certain counties will overlap, right? And so you want to take information about columns that are overlapping, and then be able to figure out where you can do these merges or joins. And there's actually 4 types of different merges or joins that you can do. So probably the most common one is the inner join. Can people actually see this? There's a lot of these white dots. Let me see here. Okay, actually, I'm gonna just do this because there are no white dots on this side. Alright. I haven't done a chalkboard in a while. Okay, so I'm just gonna write this again really quickly. Table 1, X, Y, A, B, C, D, 1, 2, 3, 4, X, Z, C, D, E, F, 5, 6, 7, 8. Okay. So the first one I was mentioning is the inner join. Okay, so if you imagine that these 2 tables are in kind of a Venn diagram, so this is table 1, table 2. The inner join is where we overlap, okay? And so I'm going to be joining these tables by where the columns are containing kind of like the same information. So right, in the example that I was giving with like vehicle sales and census data, we are joining it on the county column, right? So for an inner join, I would combine the tables together where I have values on both sides. And so where is my overlap between these two? C and D, right? So X will be C and D, and then I just carry over the information that's in table 1, right? And so this would be 1 and 2, and in Z, this would be 5 and 6. Okay?
It shouldn't be 3 and 4 for Y.
Oh, yes. Thank you. That was just a test. You guys passed. Good job for paying attention. 3 and 4. Great. Straightforward, right? We can see how we get from here to here with the overlap in here. But actually, this is only one type of join that you can do. There are other types. So this is a left join. And that is where I actually want to preserve all of the information in one of my tables, okay? And so in this case, we refer to the first one as the left one, and then the second one as the right one. And so here, I would have X, Y, Z, and I'm gonna keep everything in my first table. So A, B, C, D, 1, 2, 3, 4. And I do my join, and I get this same thing for these values, 5 and 6. Okay, but I don't have corresponding values in table 2. So what do I put here? NAs, yeah, exactly. So that's a left join. right join x, y, z, right? So, kind of the same thing, except I'm doing it on this side. So C, D, E, F. I'm going to preserve all of the information in the second table. So 5, 6, 7, 8. Here it's going to be 3, 4 for Y. I don't have information in E and F and A. Okay? Alright, so can you guys guess what the last one's going to be? Huh? Outer join, yes. Okay, outer join. And this preserves all of the information. So X, Y, Z, A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, 7, 8, and A, and A, and A, and A. Okay? Yeah, so hopefully that's pretty straightforward. Push this back out of the way. So this is something that we can implement in R. So we can just do the exact example that I just showed on the board. A, B, C, D, and Y is equal to 1 to 4. Table 2, data frame is X equals C, C, D, E, F. And Z is equal to 5 to 8. Okay. Run both of these guys, and I can take a look at table 1, table 2. Great. That is what I expected. Okay, so the inner join is like this. Table A, table 1, not table A. Y equals table 2. So I am telling R to merge table 1 and table 2 together, but I need to give a little bit more information. And what would that be? What do you guys think?
The row when you want to smoosh.
Not the row, but the column. Yes, that's right. So which thing is the thing that are overlapping? And you do that by saying by equals X. So in the real world, when you have your vehicle sales, too animated. Sorry. Okay, in the real world, when I have my vehicle sales data and my census data, like the name of the column is probably not going to be exactly the same in my two data sets. So in that case, when two column names don't match, then you do merge X equals, right, dot, 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 Y equals, dot, 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 and then instead of by equals one thing, you can have a by dot X equals name 1, and then by dot Y equals something like this. So if the column name is not conveniently X and X, you can have the name of the column in the X table that you want to join, and the name of the column in the Y table that you want to join, and you would specify it like this. Okay, so the default setting for this is just like this, and the default for merge is the inner join. I hit enter, And indeed, what we see here should match our intuition about what happens in the inner join that I showed on the blackboard. Okay? So CD 3, 4, 5, 6. And let's just look at the other options. Left join. So you do this. I'm just gonna copy and paste. It's exactly the same, but I have one additional option, all.x equals true, which means keep everything in the x table that I'm putting in. Great. And as you guys saw, left join NA for a row that contains the AB12, and that's what we see here as well. Okay. For a right join, how do you think we modify this? Anyone? All.y, yes, great. So, keeps all of the information from table 2, which we're saying is in the y, and it looks like this. And the last one, outer join. Okay, I'm just gonna copy and paste. Instead of all.x equals true or all.y equals true, we just say all equals true, and that keeps everything. Great. Okay. So that's most of what I wanted to cover today. There is one other important topic that is also very important, but we don't have time in our tutorial week to go through it, which is visualizations. And R has a whole way of plotting things, a default base version of doing that. But actually most people use a package called ggplot2 that is a much more powerful plotting device. And so what I'm gonna do, so I'm gonna provide kind of a generalized structure of how you would go about doing this, but actually, okay, rather than kind of take time to do this explicitly, we may show some examples of this as we go through the class, and that should help a little bit, but I'm gonna provide an online kind of tutorial walkthrough, a really good one actually, that will kind of help you figure out all the like options and settings for ggplot. And that should be enough of a resource that you should be able to do most of the plotting that you want to do for your like homeworks and project and that sort of thing. That being said, it is teaching you how to do how to code a visualization, a plot, and like how to use options to do certain things. But it's not actually telling you anything about like conceptually how you should be building a visualization. And so I think it's actually a lot more important. I think a lot of students tend to approach this a little bit differently, right? So these are kind of like the 3 steps to data visualization, right? And so the tutorial and that resource that I'm going to provide you is going to teach you how to do 3, okay? It's not going to teach you how to do 1 and 2. And arguably, like, 1 is the most important. A lot of people will have data and they'll just like start throwing it into plots. And that is a inefficient way and usually a poor way of getting a good visualization. So I would encourage you guys that like don't even worry about how to set up the data and don't even worry about how to plot the data until you know what it is that you actually want to plot, okay? So that step involves like kind of internally visualizing or even like sketching out on a piece of paper, like this is what I kind of expect I would want my visualization to look like. And that's gonna force you to kind of understand the data and kind of preemptively kind of know what it is that you want to visualize. And once you have that step, then it's about just execution, right? It's about getting your data into the right structure and then plotting it. And so, yes, you do need to learn how to do 2 and 3, and that can be a learning curve and all of that, but you'll eventually learn how to do that. But element 1 is the one that some people never learn to do, and that's the step that you really don't want to be skipping, okay? So please make sure to do that. Okay, last thing for today. For all of the assignments, we don't want just like willy-nilly submissions, okay? So we actually are gonna provide an R Markdown form or homework template for you guys to use. So all the folks who are going to be doing it in Python, obviously you can't do that, but we want your submissions to be in like standard Jupyter notebook, right? That's what you want? Yes. Okay. And then for all the people doing R, we want to do an R Markdown. So for those who are not familiar with what R Markdown is, this is like an extra feature in RStudio that actually lets you compile code and kind of like documentation together in kind of a neat sort of organized way. And so let me show quickly an example of this. So I put this example together here. And this is like a very generalized template that you should be able to use. And actually, there is a specific template that I put in the Canvas files for homeworks that you guys can just modify to use. So the syntax for this is like not too complicated. You can kind of see here, and I have a walkthrough kind of meta description of all of this. And these are instructions that will help you with different commands in the R Markdown file that you guys are welcome to kind of look through. And what ends up happening is you do this thing called knit, which will put this together into either a PDF or an HTML document that looks something like this. Please work. Okay, so it's processing, great, okay. And so from all of that code, you'll get this kind of document. And so this is kind of the output and the code is the input, and you can see how that like lines up with what's in the code and what gets spit out in terms of like headers, you know, these bullets, text sections versus code chunks, right? So this is like chunks of code that you want to show, and even like plots and stuff like that. And so I have additional resources here and links that can help you with this, but we've also provided explicitly an R Markdown homework template form that you guys can just kind of fill out. So hopefully with these 2 resources, even for those who haven't done this before, you can work through and figure out how to do these for the homework. And of course, we're available office hours and contact us. Yeah, that's it for today. And next week, we will just dive straight into the material.